Hey everybody, so we are going to be talking about our final transformation, and that is dilations. Now, a dilation is either a reduction or an enlargement, meaning it's either getting bigger or it's getting smaller. So think about reduce, enlarge, larger. Now, it's done on a fixed, it's done so with respect to a fixed point. Now, this point is called the center of dilation. Okay. And a dilation, this is the example of a non-rigid transformation. All of the other transformations that we've spoken about so far, those are rigid transformations because the shape stays the same. The orientation changes, but that's about it. If it's a non-rigid transformation, okay, it'll end up most of the time creating similar figures just like dilations do. That won't always be true, but it is one of the points that do occur with dilations. This means what's going to happen when you have non-rigid transformations. This is huge. Your dilations will give you proportionals. So you're going to be working with proportions again. And your angles are still going to stay the same. All it is like you've got a small sticky note and a big sticky note. They're both squares still, but one's smaller than the other. Now the scale factor, which is, we use the letter K here for it, typically a lowercase k. This indicates how much the figure will either enlarge or reduce. So remember, if it's an enlargement, it's getting larger, so it's going to be that it's larger than 1. So the absolute value of k is greater than 1. If it's more than 1, if it's greater than 1, you can write it down this way. Greater than 1, greater the image. Yeah, and that makes sense. If you multiply something by something bigger, it's going to get bigger. Now, a reduction, if you multiply it with something that's between 0 and 1. So typically that means we're working with a fraction. That's not always the case, but typically it is notified as a fraction and shown that way. So this is going to be that it's between 0 and 1. Okay, so we are going to go ahead and work on dilation. Now, there are two ways that you can do it. First, it could be that it's centered on the origin. Then you can do it where it's centered around other points. We're going to start off with the origin first. This one has a pretty easy algebraic expression for you to work with. It just says xy goes to your dilation is being multiplied. Scale factor. Factors are things that are what you multiply together to get your product. So you've got kx and ky as your final answer, as your image. So let's try some. You'll notice, by the way, that this is an enlargement because my k value is more than 2. So that's why I know that it's an enlargement. It's greater than 1. What I like to do is I list out my original points. And this is to get you ready for the next part of this. That's why I always like to write down my original points. And it's just easier to work with. Now, sometimes you won't be always told to find it for all of them, and you just need to do one. That's great. You're going to still apply the same process. And what I always like to do also is put our algebraic expression over what we're doing. In this case, our k is 2, so we're going to be 2x, 2y, which means you're multiplying each of those x values and y values in order to get your image. So r prime would be -10, -2, because all you did was multiply it by 2. And I think, oops, I made that negative when it actually wasn't. Right, then you've got -3, 4, you're going to double that, and you get -6, 8, and you get 4, -2. And so this right here would be, in fact, your final answer. So I'm just going to put these in my box over here. There we go, and here is my final answer. And it's really that easy. All right, so number 2, you're seeing a fraction, you're like, oh my God. Don't worry, it's okay. Now, when your k value is a half, that means it's between 0 and 1, which means we're going to be making it smaller. Think about it. If you're halving something, then you are going to make it smaller. So we've got j, k, l, and m. We've got -10, 2, -2, 8, 6, 2, and -2, -4. We've got our expression. And in this case, since our k is half, we're going to do 1/2 x and 1/2 y as our algebraic representation for this. What that means is all we're going to be doing to find our new values and our new coordinates is we are going to be halving each of these values. And I just like to go down the row, still down the row, down the column, whichever way you want to do it, because the dilation is the same on both your x and your y coordinate to be a true dilation, or else you end up skewing your picture. So half of negative 10 would be negative 5, half of 2 is 1, half of negative 2 is 1, and then half of 8 is 4, and then you can finish the rest. Make sure you are careful about your signs, because that is typically where most people mess up. And these right here would be our final answer. So put a box around it, and as you're looking at number 3, you'll notice, oh, it's a fraction, and if you're automatically assuming it's a reduction, that's how they get you. 5 halves is more than 1, which means it's going to be an enlargement. All right, I am going to do d prime with you. So d and e prime with you. You will have to finish the rest of this square. So go ahead and write your original points. Then we've got our algebraic expression. This is 5 halves x times 5 halves y. So the way I like to do it, if you struggle with fractions, then I like to use my original point when I'm doing this. And remember, I'm only showing you d prime and e prime. And you are responsible for f prime and g prime. So d prime, this one's kind of easy. 5 halves times 0. That's going to be 0. And 0 times 5 halves, well, that's 0. When you have the origin, it just kind of stays the same. With e prime, you're going to be multiplying 2 times 5 halves. So if you want to think about it this way, it would be great. It's 2 times 5. We're multiplying straight across, and then dividing by our denominator of 2. So 2 times 5 is 10. And then divided by 2 will get you a 5. Then you've also got that 4 in your y value times 5 over 2. That 5 over 2 that we're working with. So 4 times 5 is 20 divided by 2. And that gets you a 10. Remember, you have to finish this one off to get f prime and g prime. All right, next one, our favorite one. This is from other points. I'm going to be using colors for this, and it's very similar to exactly what we've been doing with the reflections when they're over a line that's not the axis, and a rotation that is not the origin. Same thing with the dilation. Your first step is going to be to move it home, aka to the origin. Then we are going to apply our transformation. Okay, and in this case, that is going to be our dilation, and that's fine. Honestly, these steps are all the same. Only thing that actually changes is the actual transformation that we are applying. And then what you're going to do is your final step, you are going to go back to the point that you were given. So in this case, to our center of dilation. All right, so we are going to be using vectors. You can use translation, the algebraic representation, but with the vectors, it's just a whole lot easier to work with and a whole lot cleaner, frankly. First step, write down your original point. So I've got R, S, T, negative 4, 9, negative 3, 3, 3, 10. All right, and then you're going to be moving it, and you're going to be doing a couple of different steps. And I am labeling what's happening at the bottom. So these right here, this is my pre-image. And I'm going to end up with my image points right here. First step, we are going to have to move home. So move it to the origin. We're starting at negative 2, 7, with a scale factor of 2, by the way. So let's move it to the origin by doing the opposite. And we're moving it home. And this is where I just like to go down the column and apply it. So I'm going to add 2 to all of my x values. Then I'm going to subtract 7 from all of my y values. All right, first step is done. My next step, actually apply the transformation. So for my transformation, I am dilating. And in this case, you'll notice that it's an enlargement because my scale factor is more than 1. So what we're going to do is we are going to multiply each of these by 2. And again, you can go down the column or across the point. So I'm going to get negative 4, 4, negative 2, negative 8, 20, 10, I applied a little too much, and 6. And now you're going to go back home. So we went to the right 2, down 7 to get to the origin. Now we're going to do the opposite, and we're going to subtract 2 and go up 7 to get back to our original center of dilation. So I'm going to subtract 2 all the way down. And then I'm going to add 7 all the way down. And this would be our final answer. All right, last one. This is our parallelogram. You guys are seeing the fraction. Don't worry. It works itself out. I promise you. I am going to do point J and K with you. You will be responsible for L and M. So first steps first. There we go. We are going to write down our original points. So I've got J, K, L, and M. -1, 8, 5, 6, 7, -2, 1, 0. This, again, is our pre-image. You're going to end up moving it home. Which means you're going to move this closest, you're going to move it back to the origin, which means you're going the opposite direction of where that point is. You just flip the signs of that center. So add 3 to all of your x values. And then add 2 to all of your y values. Remember, you are doing both of the last points. I am only doing the first 2 with you. Next up, we are going to apply the dilation. This one, you're going to be doing half of x and half of y. The way this works out is you will get nice numbers. If you don't get nice numbers, say you end up getting half, then it's a half. And it's okay. Those are still numbers, guys. So half of 2 is 1, half of 10 is 5, half of 8 is 4, and so we've got those points. Last step, go back. Okay, so we are going to do -3, -2, which was our original point, subtract 3 from our x values, and subtract 2 from our y values. You are responsible for doing L and M. All right, so a lot of math, just algebra, just remembering what those rules are. Now, here's the deal. You will have to work backwards sometimes. You want to identify the center of dilation, or identify the scale factor. This is what we're going to be working with. For the center of dilation, all you're doing is that you're going to draw lines, and the intersection of those lines, that's the center of dilation. So try to make it as accurate as possible using slope, and that would be great. For your scale factor, a good way to keep it and remember it is that K is your new over your old. Pretty much, you like the new things over your old things. And for most of us, that's true. We like to use our new phones over our old phones. If we get a new planner like I am, I like to use that instead of my old one. All right, so let's go ahead and find our center. This one's easy. My slope is vertical. Okay, let me do this next line. And I'm color coding to help you see a little bit better, but you do not need to. And then lastly, the last one, I'm going to go up 2 over 4, which means my slope is going to be 1 over 2. And check that out. In this case, our center is the origin, which is 0, 0. Now, you're looking at this and you see that your table is getting smaller, your triangle is getting smaller. So you know it's going to be a reduction. You can tell that from D and D prime. So I like to see that automatically, so I know that my scale factor, it has to be between 0 and 1. All right. Now what we are going to have to do is we're going to have to find the length. So I am going to use some different colors just so we can stick it out. And I'm going to find right here the distance of DE, just because it seems a whole lot easier. And I'm doing the Pythagorean theorem method. The length of D prime E prime is the square root of 2 squared plus 2 squared, which is square root of 4 plus 4, which is square root of 8. If you're simplifying your radicals, which you should be if you're in pre-AP, you get 2 square root of 2. So 2 square root of 2 for my new. Remember, K is new over old. And then I'm going to do my old. So this is going to be a 6 by 6 So I'm doing Pythagorean theorem method again, and this measure of DE is going to be the square root of 6 squared plus 6 squared, which is the square root of 36 plus 36, which is the square root of 72, and that evens out to be, simplifies to be 6 square root of 2. If I simplify this out, you'll notice that the square roots of 2 won out, and 2 over 6 simplifies to be 1/3. So this right here would be my scale factor. All right, so for number 2, I am going to have you find the scale factor. Notice that it is a reduction. That is super important because that'll give you an idea of what you're working with. Find the distance of one segment because it's a dilation, it's all the same. And then do new over old and simplify that fraction. Now your center for this one, it seems to be a little bit different. Your slope of L prime to L is 3 over 2. Okay, well that's interesting. Can't really do too much with that one. Okay, I am going to then do M and M prime, and I'm going down 2 into the right 6, so it's down 1 over 3. And you can use a ruler or whichever you want, and I'm going to try and erase this. Or what you can do is you can draw these points in to kind of help guide your way. Right? And you're kind of seeing that it's going to be 1/6, but let's go ahead and confirm. We're going to go up 1 to the left 5, up 1 to the left 5, and oh my goodness, yes, it is, in fact, 1/6 for the center here. Okay, last problem that we're going to be doing is you are going to be responsible for number 3. And I am going to, actually, that's a lie. You will be responsible for number 4, and I will do number 3 with you. All right, so all it is that you are just using your new over old again, or you can use your algebraic expression. I'm going to go with the algebraic expression one first, where it's going to be 2x, 2y, since it's a scale factor of 2. We know that it's going to end up equaling a prime, which is -10, -8. So what we're going to do is in order to solve, we're going to do the opposite and divide each of these by 2, which gets us x, y is going to equal -5 and -4. And this right here is a. The other way to do it is k equals nu over old, so you just pick one point or one coordinate, and you know your scale factor is 2, so you put your new point over your old point and solve for x. Solving for x, you get 2x is equal to -10, and then x is equal to -5. Same thing that we got here. You're going to get something similar for number 4. You are working with fractions here. And by the way, the algebraic representation one is so much easier. But remember, when you're dividing something by 3, that's the same as you multiplying it by 1/3. So keep that in mind when you do your inverse operations, all right? Thanks for watching.